So sometimes with these imperfect squares, or these you need to know how to approximate, because they're giving decimals, and you need to find a way to say, well, this number fits between this and this. So remember, we're dealing with 2s, 3s, 4s, 5s, whole numbers, these integers, these whole numbers. And what you're trying to do is to say, well, this fits between this whole number, this, and this whole number, that. Remember on the previous one, we had the example, square root of 5. And we said, well, the square root of 5, I don't know, but I do know the square root of 4. The square root of 4 is 2. And I do know the square root of 9, which is 3. That means that this 5, the square root of 5, is going to fit somewhere between the whole number 2 and the whole number 3. Means it is a decimal. It's going to be 2 point something. I don't know, but it's between 2 and 3. If I take another one, let's look at the square root of 7. Hey, isn't the square root of 7 also going to fit between the whole numbers 2 and 3? The answer is yes. Now, I've got a question for you. Is that number, the square root of 2, or square root of 7, is it going to be closer to 2? Or do you think that number is going to be closer to 3? So this is trickier now. So if I ask you this kind of question, I'm actually asking you to infer, because you have to think about it. Let's get rid of the square root of 5, and let's put that square root of 7 right in there again. So it's asking you, oh, so interesting here, square root of 7. So now let's take a look at this. Let's make some inferences, okay? Hey, how far is the number 4 to the number 7? You would say, well, 4, 5, 6, 7 is 3 numbers away. I'd say, yeah. Remember about distance, right? Distance. And I'd say, well, how far is the number from 7 to 9? You'd say, oh, that's 2. So let me ask you a question. Just by distance alone, is the number 7 going to be closer to the number 4, or is it going to be closer to the number 9? Well, hopefully you'd say, well, if distance is only 2 numbers and this one's 3 numbers, then you'd say, well, it looks like whatever that is it's going to be leaning towards that 3. It's going to be on this side. So I'm going to say, yes, that side of what? And you'd say, well, that side of halfway, right? Now, if I said, yeah, that's right, this 7 is on the right side of halfway. Now, halfway between the number 2 and 3, guess what? Is the number 2.5. 2.5 is between the number 2 and 3, 2.5, right? So that means that whatever this is, because its distance is shorter, it's closer to the 3, which means it's on this side of 2.5. Now, on the test, they may ask you to do something this detailed, but for us, for right now, let's just figure out which 2 whole numbers this thing is between. Look at this one. We have to think about the square root of 30. Oh. Now, can you think about the whole numbers that are squared that are between 30? Well, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Oh, we're getting close. And 6 squared is 36. Now I've passed it. So this square root of 30 is between the square root of 25, which is a 5, and the square root of 36, which is a 6. That means this is between the whole numbers 5 and 6. It makes it 5 point something. I don't know. 5 point something. That's good enough. Now, if you want to get more detailed and say, well, what's it closer to? 5.5 is halfway, right? Well, if I said, is it leaning more towards the 6? Or is it leaning more towards the 5? Well, that's something to think about. And you can use the distance. Between 25 and 30 is 5 units. Between 30 and 6 is 6 units. Is it closer to the 5? Or is it closer to the 6? If you said it's on the left side of 5.5, It's on the left side of halfway because it's closer. It's only 5 units away. Means it's closer. So I would say yes. This number is going to be less than 5.5. What it is, I don't know, but I know it's less than 5.5. So again, you might not have to get this detailed, but if it does come to that, that's what they're doing.